Okay, well, good morning. For this video, we're going to cover a couple of topics. We're going to look at endothermic and exothermic reactions. And what in the world is all that about? I've had requests from students trying to explain that a little bit more amongst with some other things. But I'm thinking the endothermic, exothermic reaction is probably one that would be big. So, I mean, when we look at the term endothermic and exothermic, okay, we have to break down the words, okay? When we look at the word thermic, okay, we should automatically, we think about thermometer, thermostat, thermal blanket, okay, a thermos. So it has something to do with heat. And that's the thing. In any chemical reaction, there is going to be some kind of heat in the form of energy. Well, I should say energy in the form of heat. Okay? Now, that being said, well, what's happening in a chemical reaction? Well, either energy in the form of heat is being given off or it's being absorbed. It depends on the kind of reaction you're looking at. When we look at endo versus exo, well, look at the word endo. Endo, think back to biology. When we talk about the endoskeleton of mammals, for example, like us, we have an endoskeleton, which means endo means inside. So when we look at endothermic, we're looking in this sense of inside heat. Well, wait a minute, what do you mean by inside heat? Well, the idea, guys, is it is heat that's being absorbed. It's being absorbed by the reactants, and that energy is used to put atoms together in a different way, okay? Or maybe to take them apart and rearrange them. Depends on the reaction. So some reactions are endothermic, exothermic. Exo, think about excite or exhale. Okay, or exit or exodus, like the second book of the Bible. Basically, the Moses leading his people out of Egypt. Okay, so that means it's an outward heat, an out heat. Well, what do we mean by outward heat? In other words, heat energy is being given off. Now, what about examples? Well, if we look at examples of endothermic and exothermic reactions, exothermic is probably a lot easier because we can think about explosions. We can look at fireworks. Those are great examples of exothermic reactions. Well, why? Because they give off heat. When you have a campfire and you're roasting s'mores, okay, those would be examples, that would be an example of an exothermic reaction, okay, because you've got heat being given off. All right, that would be a key thing, or energy being given off, even light. Remember, light is a form of energy. We did talk about that in an earlier time. Okay, so endo, on the other hand, when you're mixing things together and the heat's being absorbed, well, how in the world do we know if it's an exo or an endothermic reaction? Well, here's a big clue. I'm going to draw a graph here of temperature versus time. Starting at time 0, and we'll just put infinity here for the sake of argument. And we're going to say a low temperature to a high temperature. Okay? So this is our temperature versus time graph. Now remember, if we're looking at a system, let's say we've got ourselves a glass. Okay, and in this glass we have our thermometer right down here, and in this glass we have got some green stuff in here, and then we add some blue stuff in here, so we're creating two reactants. So how do we know if something is an endo or an exothermic reaction? Well, the idea, ladies and gentlemen, is this. What's happening? How is the thermometer responding? If heat is being absorbed by the reactants, then the heat is going to be pulled out of the solution and into the molecules themselves that they're going to be forming. Because it does take energy to build up bonds. It does. Okay? And there's usually in a chemical reaction, you have a combination of breaking bonds and putting bonds together. That's pretty much it. So breaking atoms apart and putting other atoms together. So if you're breaking bonds, you're going to get energy that is released. If you put bonds together, it absorbs energy in order for that to happen. And usually what's going on is you have more bonds being put together. That takes up more energy. So overall in the reaction, you're going to see the heat energy being taken out of the surroundings and go into the molecules themselves. And what happens is you end up seeing a decrease in the temperature. Why? Because all the heat energy is not coming into the thermometer. The heat energy is going into making these new bonds, creating this new product. So if we have a curve, a temperature time curve, it's going to look something like this. Okay, so you're going to see that the temperature will drop. What does that indicate? It indicates an endothermic reaction because the heat is being absorbed by our reactants to make new product. And the thermometer is not picking up this extra heat. The thermometer is realizing, oh, we got less heat, so the temperature is going to go down. That's how we know it's an endothermic reaction. Well, what about exothermic reaction? Well, exo is the exact opposite. Okay? If we look at an exothermic reaction, we have reactants that are being broken up and bonds being formed. And what happens is you've got all this extra heat energy that's inside here, inside the solution, inside the reactants as things are changing. So this heat is going to be absorbed by the thermometer. Because it's not all of a sudden the thermometer is going, oh, hey, I got all this heat energy, time for me to raise up my temperature to say, hey, I've got a bunch of this heat energy. So what in the world is that going to look like? Well, it's going to look something like this. You're going to see a graph that you're going to see a temperature thing like this. Now, what examples are there of endothermic and exothermic reactions? Well, there's an endothermic reaction example in your notes of the beaker that's attached to a piece of wood that has a little bit of water on it, and you put the beaker on, you add the chemicals, and it causes the water to freeze because it's sucking out the heat energy, and it causes the beaker to be stuck to the wood. That's the thing. So that's an endothermic reaction. Here's another one. We did this experiment earlier in the year, toward the very beginning, where we mixed baking soda and vinegar. And I had you guys mix it first so you could see that, ooh, it's all bubbly and fizzy, and then we repeated the reaction again, except this time we took a thermometer and then we were monitoring the energy changes, and what you found was, in the energy change, you had a dip. You saw the temperature go down, and then as you saw that temperature go down, all right, so as I hear, it went down, and then it was starting to climb back up. And if you were monitoring it over time, you're going to see it go back to here. Guess what? That's the chemical equilibrium. Remember that Henry Le Chatelier dude about things responding and going back and forth? This is just going back to an equilibrium where things are being reformed and deformed and then going back and forth. But this here, this is an endothermic reaction. And that, ladies and gentlemen, that's our clue that the temperature is going down. What about, we already talked about the exothermic, so I'm going to close with examples of exothermic reactions. Think about paper burning, wood burning, okay? Lighting magnesium on fire, fireworks, okay? Lighting gasoline on fire, for example. What happens with the gasoline inside the internal combustion engine? All those are examples of exothermic reactions, because you've got some kind of an explosion, you've got heat energy being given off. All right, hey, I'm hoping that this video will help you guys out. You take it easy and have a good one.